Okay, so in this problem, we have a binomial times a binomial. It's the same as if you had x plus 1 times x plus 2. You're going to use FOIL, distribution, box method, whatever you like. So we're going to say negative 3 times 2 is negative 6. And then negative 3 times square root of 3 is going to be negative 3 square root of 3. And then the inside times inside, so minus 2 square root of 3. And then last but not least is going to be minus, and then square root of 3 times square root of 3 is square root of 9. So when you have radicals, you can multiply the radicand times the radicand, or the coefficient times the coefficients. Don't mix them up. Now we know that square root of 9 is the same thing as saying 3. Okay? Let's clean this up a little bit. Now I'm looking for like terms. So I can see I have a minus 6 and a minus 3. So that's negative 9. And then here I have like radicals. You have a like radical, you have to have the same index and the same radicand. And when you have that situation, all you need to do is add the coefficients. So it's going to be minus 5 square root of 3. Now, if you wrote it the other way, minus 5 square root of 3 minus 9, that's okay too. Negative 5 square root of 3 minus 9 is the same answer. Either one is correct. Okay, we'll just check ourselves. That looks right. Let's move on to our next problem. Now this one is solving, so we're no longer just simplifying. If you notice, the difference is now I have a 0 on this other side. Before I had nothing on the other side. So when I'm simplifying, I only have one side of the equation, but when I'm solving, I have both. So let's see, I have square root of 4p minus 3, and then minus 6 is equal to 0. Notice this minus 6 is not under the radical. So my first step is to get the radical all by itself. So I want to get all of this alone, the radical. So I want to add 6 to both sides. Now, when I add 6 to both sides, now I have isolated my radical. To solve a radical, it's very easy. You just raise both sides to the power of the index. Well, I don't have an index here, do I? There's no little number here. When I don't have a number, I know it's really a 2. That's what we're going to assume always. So I'm going to raise both sides to the power of 2. When I raise a radical to the index, it just becomes the radicand. Okay, so let's make sure that always that whatever you have here will now become the left side of your equation. So when you raise a radical to its index, you get the radicand. And the other side would be 6 times 6, which is 36. So now I'm just going to solve for p. And then I go, oh my goodness, p is equal to 39/4. It's a fraction. That's okay. That really is your answer. P is equal to 39/4. It's okay. But when you're dealing with radicals, you must check your answers, because you might create extraneous solutions. So it's not a matter of being goody two-shoes. You need to put this back into your equation and making sure that it's true. Okay, so let's do that. So I'm going to put 39/4 back into my equation. So 4, I made that one too long, sorry. 4 times 39/4 minus 3, and then remember the minus 6 is not in the equation. So this becomes 39 minus 3 is 36. And that's going to be 6 minus 6 is equal to 0. That is a true statement. So this is my solution, 39/4. Okay, now let's look at this next one. Let me clear all this because I think this is wrong. Yep. Okay, so the next one asks us to graph a radical. Okay, so you don't know what you're going to get. So when you're graphing a radical, the first thing you look for is the domain. And that's why I asked you in part A, what is the domain? So when you have an odd index, the domain is all real numbers. So negative infinity to positive infinity. When you have an even index, so it's either 2, 4, 6, 8, 0, or some even index, then you have to limit your domain. Your domain for an even index is you're going to say the radicand has to be greater than or equal to 0. Your radicand is your stuff under your radical sign. So for our problem, we have an even index. So we have negative square root of x minus 1 is equal to the function output of x. So our index we know is a 2 because we don't see 1. Our radicand is only the stuff under the radical. So don't get confused, it's only this. That's my radicand. So I'm going to say whatever that is, in this case it's x, has to be greater than or equal to 0. That is going to be my domain. Now, it doesn't want to as an algebraic inequality. We want to have it here as a interval notation. So let's just go ahead and draw that on the number line. So if x is greater than or equal to 0, it would look like this. So if I were to write that in interval notation, that's going to be 0 to infinity. The infinity side always gets a parentheses, and our left side gets a bracket because it's a colored in circle. Okay? Now, if I want to graph my equation, now I know my domain, that my x has to be greater than or equal to 0. So let me just go ahead and pick a point or two to put on there too. Okay. So if I made myself a little quickie table, and I know all my numbers have to be greater than 0. So if I put in a 0 for x, I get negative square root of 0 to 0 plus 1. It's going to be 1. And let me just put in a number that I know the square root of. So I'm going to put in a 4. And the reason is because now I can say negative the square root of 4 plus 1. So I deliberately chose 4 because I know that square root of 4 is 2. So negative 2 plus 1 would be negative 1. I'm going to pick one more just for fun. So I'm going to pick 9. Once again, I picked it because I know the square root of 9 is 3. So negative 3 plus 1 is negative 2. So I can graph these 3 order pairs if I need to. So 0, 1. Oh, now be very careful here. Let me just go ahead and show you what I mean by this. Let me make this a little lower. All right, so now when you're graphing this, since a radical, an even index always has this shape. Is it even? And an odd index always has this snake-like shape. This is my index. Okay? Well, we have an even index, so it's going to have this shape. So I want to make sure I use this tool right here. Okay? So I'm going to go 0, 1. That's my first point. And then I want to graph the second point. So I'm going to say 4, negative 1. Okay? And I can check, oh, there's my other one, 9, negative 2. That worked perfect. Okay? So now I have graphed my equation. And then my last one says, use the graphs to determine the range of the function. Now we know domain is as far left to as far right as you go. So if you look at it, let's just check our answer. So we said earlier that our domain would be 0 to infinity. Remember we put 2 zeros, little O's for that. Okay, that's going to be our as far left to as far right. Okay. And then our range is as low as low as we can go to as high. Now, it may look like the lowest we go is negative 2-ish, but actually we know there's an arrow. It doesn't show here, but in real life it looks like this and has an arrow, which means it goes on and on forever and ever. So our range is going to be negative infinity, okay? And our highest that we're going to go, though, is going to be 1. And we include that, so we're going to put a bracket. Okay, and so we got that problem right too. Okay, let's do problem number 8. So problem number 8 is a complex number problem. This should be a nice easy one because we treat it just like we do with variables. Okay, so when we add or subtract, in this case we're going to subtract. We treat it just like if it was an x. Notice I put a little hook in my eye so it doesn't get confusing with it as if it's a 1. Now, whenever I have a minus between two sets of parentheses, I know I have to distribute that. So this minus makes this become a minus 5 and a plus 17i. It's like having a 1 here that you had to distribute to both terms, and that will change the signs. So once I take out all the parentheses, I'm just looking for like terms. So I have a minus 4 and a minus 5, which is negative 9. And then I have minus 15 and a plus 17. So a negative 15 plus 17, I can use my calculator if I'm really stuck, we plus 2i, just as if it were like an x. So I'm saying this exactly the same way had I done this problem with an x. So far, I'm going to get the exact same answer, right? So it'd be the exact same method as if it were the variable were an x. We know it's not an x, so it's an I, because it stands for imaginary. So our answer is going to be negative 9 plus 2i. So we put this in negative 9 plus 2i, okay? And that's right. Now, one more quick note on this problem. Now, if you notice, it says write your response in A plus BI format. So in the last problem I told you, it didn't matter if you had the order differently, but in this it does, because this is a complex number. It has a real part and it has an imaginary part. And to be in standard form, we have to have them in this real first and then your imaginary part second. So make sure that you put them in the order of negative 9 plus 2i, because if you put in 2i minus 9, this would be wrong because that would have the imaginary number first.